Okay, so let's get this thing going. No worries, the first part is, you already know the first part of the presentation. Well, you've met me this morning, hopefully. For those of you that were not at the keynote or arrived later than the keynote, I'm Ana. I'm happy to be here again with you, and we're going to talk about Helm in this session and how to use it in better handling Kubernetes complexity. Those being said, let's go a little bit into the Kubernetes challenges and why to use Helm. So one thing to know about when dealing with Kubernetes and also when working with microservices is that you have to manage and update a lot of Kubernetes configurations even for a single application. And if you're thinking like many microservices or many applications, those configurations multiply. So this ends up most of the time in, well, writing a lot of YAML files. And maintaining all these YAML files is becoming a burden. Secondly, it's difficult to, well, achieve that deployment of many configurations as a single application. Because if for a microservice you have multiple configurations provided as config maps or as secrets, you have to maintain those and deploy, and you want to deploy them all at once, right? So a solution around that when using just plain Kubernetes YAML files is to write very, very, very long YAML files, which are scrollable. You sometimes start reading into those. You kind of forget where you started, what were you actually looking into that file, what that file is for, and what it's describing. So you kind of need a map on when walking in such a YAML file. Thirdly, when you are managing microservices and actually applications across different types of environments or namespaces, you're kind of thinking that, well, a lot of my objects and Kubernetes objects are kind of the same, but I only change a few values, so why don't I use those values as parameters? I want to be able to give parameters to those configurations that I'm doing in Kubernetes. So parameterizing for multiple environment support is not exactly out of the box when using directly YAML Kubernetes files. And this is where Helm is coming to your rescue. So Helm is kind of helping you to manage and package your Kubernetes application, and it makes it easier for you to work with Kubernetes objects. Firstly, let's discuss why Helm and what is Helm. So Helm is Helm 2, because we're going to talk a little bit about Helm 3 also. Helm 2 is coming with two parts, the client and the server. The client is the one that you're having in your local computer or in your pipeline, is the one that's issuing commands to the tiller that's residing in your cluster. And the tiller is the one that's actually conversating with the API server and telling the API server what objects to instantiate there. Typically, when working with Helm 2, you're using the helm init command to make sure that, well, your client and your tiller are connected. And another thing to be known about Helm is that it helps you to create your own charts. What charts mean is actually that it provides to you a set of templates that can be reused across those environments. And of course, you can define multiple values files. So this means that these values files here can be differentiated per environment. And thus, you can achieve parameterization, what we were talking a little bit earlier, that, well, in Kubernetes, parameterization doesn't come out of the box. You can do that. You can parameterize per your need. And last but not least, you have the chart.yaml that is describing the set of charts that you're trying to work with. Another great thing about Helm is the fact that it has community charts. So out-of-the-box charts that are working with some very, very known frameworks or tools or databases, in this case, PostgreSQL, for example. And what Helm is very nice about is about promoting reusability. So you're using those templates for making deployment across your environments. What you're changing is just those parameters, those values that were just differentiated across environment. You're not changing in terms of objects. Another good thing about Helm, and regarding the part with the reusability thing, is the fact that it has, well, a basic command of install or upgrading your release. You're reusing the same charts. You're just giving a name for your release, and you're deploying in any namespace that you want. Of course, specifying the values that you want. And we're going to see that in the demo. But another nice thing about that is that release itself, you can identify that set of objects that are instantiated based on your templates, on your charts, using a release. This is better. This is very good for isolating what you have done and to know what release has an issue and to debug and troubleshoot later. Also, a good thing to be known about Helm 2 is that the release names were scoped to the tiller, to the namespace where tiller was running in. In jargon said, it's saying that, well, if you have a release and you have named the release in a certain way, you cannot reuse that name in another namespace. There are some workarounds around that, so some tricks for Helm 2 to reuse the same release name, but we're not going to discuss those here yet. In Helm 3, that is coming very, very soon, but is now available for testing, by the way. In Helm 3, the tiller has disappeared. The reason being is because Kubernetes API has evolved, and thus the tiller didn't make sense anymore. So you can talk directly with Helm 3, you can talk directly to the API server, you don't need the tiller anymore. But you have as a bonus the ability to reuse your charts that you defined with Helm 2 using Helm 3. So there's not this issue of like backwards compatibility. Do I have to upgrade my charts? Do I have to make any changes over there? There are a few things that need to be taken care about, like role-based access control, but in the end, most of your charts are going to work with Helm 3. Another neat thing about Helm 3, since now that we're not having the tiller anymore, is the fact that the helm init command is not needed, because there's no initialization needed between the client and the server anymore. You're just directly talking with the API server. Also with Helm 3, there's a very neat thing coming for those that wanted to reuse the same release name across namespaces, is the fact that now release names are scoped to namespaces. Because we don't have the tiller anymore, we can reuse the same release name across namespaces. There's no more conflict around that. Of course, with Helm 3, there are also some other goodies, like some commands became more familiar. For example, before we used to have Helm delete for removing a certain release, but now you can use Helm uninstall, because since you were doing install to install your charts, it makes much more sense to use uninstall. Of course, you can also work with delete and the other command over there. There are also some other commands that were improved, like search. And of course, some commands were added. And you can ask me, by the way, in the Q&A session tonight at the debate if you want more about that. So a lot of things were simplified in the end with version 3. Even though that version 3 is not yet available and still the stable version is 2, Helm 3 is making things much more easier for us to work with. So let's look a little bit at the playground overview for the today demos in the session. So we're going to work with the frequently asked question application, a small application like a microservice. You ask questions and it answers. It's very, very basic. This application stores its information in a PostgreSQL database. Both are managed with Helm Charts. And of course, I want to log and to stream my logs to an external service. That's a managed service outside of my Kubernetes cluster. And my Docker images are all stored in a container registry. So everything is happening privately for myself. Those being said, let's dive into the first demo. The first demo is about the chart per service approach. So there are several approaches when working with Helm charts for a microservices architecture, for example. One of those approaches is to define a chart per microservice. So this means that you have an application and there's a chart that describes your application over there with what you're having. And for this demo, I'm already going to use a Helm chart, so the PostgreSQL one, and I've already installed this one using a very basic command. So the Helm chart for PostgreSQL is available on the internet, on GitHub. it specifies directly what you can use. So there are a lot of parameters that can be configured. It's pretty easy to work with, pretty straightforward, and you just parameterize it per your need. That's already there in my cluster for me. Okay, so let me go here. And well, I need to create my charts for my frequently asked questions application. Set a Spring Boot app. And typically, when working with charts, you say Helm create the chart name, Helm create FAQ. The charts were created. Let's just check their description. So when treeing the FAQ, I'm seeing that I'm having a chart YAML, the one that's describing the charts that I want to deploy. By default, there's another folder called charts that is useful when I want to add charts, additional charts for my deployment. So if I need some other charts in order to make successful these installment, I can specify them there. Templates, of course, we have the notes.txt where you can specify commands for your colleagues that are going to use those charts, or other commands that are useful when these charts are installed or upgraded to see and to indicate to others on how to use them further after their installation. Helpers.tpl where you specify additional templates for your chart, so you can define your own set of rules for matching inside the templates that you're using. Of course, deployment YAML, ingress.yaml, and service.yaml are by default generated, so they have some dummy information over there. One of them, so as their name says, deployment is for the deployment object, service for service, and ingress for specifying the ingress routes. And of course, there's one for testing, the testconnection.yaml, which can be parameterized for making a basic test with Helm. And you can use the Helm test command together with this one to run this one. Now let's go into the IDE. Okay, close this one. So my FAQ, let's modify them a little bit. So these are the default ones. Just modifying my FAQ app for the description. The values that were already generated are for Nginx. And in the interest of time, I'm going to use my own set of values. As you can see here, let me just make this bigger. I am specifying, well, an image that I want to get, that I want to configure for my deployment object, a secret to get to my own, to my own container registry. Also some other information. I can also use some script for debug like hello world later on. And of course some information regarding the database that I am going to use. So in this case is PostgreSQL. And for the server, secret name and secret key, I am using, actually the server is the service name in Kubernetes of my PostgreSQL installment. The secret name is actually the secret generated by that chart installation. And the secret key is pretty standard, this PostgreSQL password. So, those being said, let's modify a little bit the templates part. So on the templates part, there are already some generations here. And the IDE is kind of replacing a few things for me to make them, in order to make sure that I'm seeing what is over there specified in the values. Modifying this one with my own generated part. So, just make it a little bit bigger. Besides the total auto-generated things, you can also add your own data, in this case the pool secret, because I'm using a private container registry. And also I added my environment variables, like the Postgres server, Postgres username, and Postgres password. These are very important for my application because my Spring Boot application is going to take these from the environment and it's going to start based on the information here. So what I'm doing, I'm actually passing from the environment all this information to the application itself. The application is never concerned about values, it's concerned about the name of those labels in the environment. Of course, I can play around with it and have some, and Helm makes it easier for me to define some default values to have a default over there just in case that I have not defined something. So this is a very neat feature. Another interesting thing to know about Helm is the fact that, well, it also has structures that can help you like controlling it, like if and else, so you can see and control if something is not defined in your values.yaml, you will not execute that sequence, and we're going to use that in a little while. Just let me modify a little bit this part because it's not working as expected since I don't have this definition in my values.yaml. So ports.port, and I'm going to use the node port type. Okay. .ports, .node port. Now, of course, the IDE plugin, it helps me a lot when I'm completing all this stuff. And another cool feature is that you can create your own templates. So for example, let's check for a secret.yaml. Okay. So I was talking to you earlier about that control structure. So for this one, for example, what it does, it checks if the logDNA agent key is defined. If that is defined, it executes what is inside this chart. If not, this is not going to be done over there. So this is a way of constraining and knowing that, well, that value is going to be over there, so I'm not going to have a failure when executing this secret.yaml. Similar to the secret, you can define also your own template for config maps. So just for that, let's go with config map.yaml. Config map. And here I've just reused the values.debug from the values file. And I want to deploy all at once this because this is what I wanted in the beginning, to be able to deploy all these configurations all at once, and this is what Helm is doing great for me. But because I'm going to deploy in the environment of dev, I'm just going to define my own set of values for dev and just use it here. So let's go and install it. Firstly, Helm install. Let's give it a name. We're going to say simple because it's a simple deployment. We're going to use the FAQ with values from FAQ/values.dev.yaml into the namespace dev. Okay, so continue creating, checking for the status of my simple release. So Helm status simple. It's up and running. Let me check. And 3 on 1925. Okay. API/questions. Cool, so I can hit the endpoint, I have a successful deployment and all is running and is great. So this is the chart per service approach, so chart per microservice approach, only for my FAQ app. However, well, when working with microservices, well, we know that microservices have their own persistent store associated, so maybe you want to spin up together the persistence unit and also the application. Or you have a way to bundle your application together with some other chart. In this case, the master chart approach is the one that would be recommended. So the all-in-one approach, or the master chart approach, works as following. You have a chart with the folder charts as discussed earlier. We're going to just copy-paste the information here into the charts folder. Okay, just delete these two. One sec. Okay, and in this case of my charts, what I'm going to do, I'm going to define with Helm 2 a requirements file. So in Helm 2, the requirements file was the place where I was defining, well, my dependencies, in this case, the PostgreSQL database, and of course the FAQ application, the one that I want to actually install. And this is the order, first the database, and afterwards the FAQ. And of course, the set of values that I can define globally for this installation. And in this case, the set of values defined globally are actually the parameters for my database. I'm going to give it a name, Postgres demo, a user, a password, and the persistence is enabled or not. So those being said, you can install it all in one by just saying again, Helm install -- name master from charts into the namespace dev. Now this is going to be a very chart. Oh, I already have something on that port. It's true. Make sure makes sense. 65. Okay. I kind of missed the delete command from Helm 2 because it was deleting, when we were deleting, you didn't have to specify the namespace. With Helm 3, you have to specify this namespace where you want to make the uninstall. So it's a little bit different. Helm status master. So it's up and running and working on 31265. Let's check it. Yep. Now, with Helm 3, the difference is that there is no more requirements file. And what was before in the requirements, it has been moved in the chart.yaml. And this is also, some part of this is auto-generated by the Helm 3. And the dependency part is put in here. So no more additional files to create with Helm 3. You're just specifying everything at the chart.yaml level, and the rest of the things are just working as before. So less things to manage. Going back to the presentation. There's also a hybrid approach. So if you're having many microservices, there's a way that you can group. So you can create the hybrid approach and have one master chart per service group. You define your own groups for your microservices, and you use the master chart approach for that group only. You have, again, one dependent chart per service, so still the one chart per service approach, but you're also combining it with the master chart approach by defining those global values.yaml. So this is the third one, and the thing the most used if you're having a lot of microservices. Depends a lot on your configuration, how many you have. Some extra care is required when using job and cron job object templates. The reason being because these objects have impact on scheduling things. And you can end up with jobs that are forever running, or that are running from time to time, and you don't know why that thing happened over there. So on these ones, typically, you kind of specify by hand the backoff limit and the active deadline seconds to make sure that they will have a finite time of working. Also, some extra care required while using secret templates. Of course, there are ways in managing secrets, not just with Helm, but also with Vault and some other tools over there. But in case of Helm, it comes with this very, very, very useful annotation, the checksum config annotation, that is actually checking if the secret definition has changed. Based on that, it will trigger another deployment. So this is an annotation that comes only with Helm, to my knowledge, and is much more useful than just using out-of-the-box Kubernetes and configuration and all the other stuff. Also, some extra care required while using role-based access control resources. So based on that .tpl file, that helper.tpl file, you can define the role-based access control resources, and you can use these things in your configurations. But you need to be very careful on how you define them and how you are how you're using them across your deployments in order not to end up blocking your deployments. And also, these need to be extra cared while upgrading from Helm version 2 to Helm version 3, because there are going to be some things to tweak around when making the upgrades. Okay, so some takeaways, because I have less than 3 seconds. Well, in a template, check for nested values at every level. So like the if-else control loops, these are very, very useful. Try to do not hard code your values in your templates, except that there are objects that need some extra care and you want to make sure that you have a certain control on those charts. Manage environments through multiple support to multiple values files, and these values files, like in my case, the values.dev can go to on how many environments you want to. And mind the way you organize your charts, either if it's chart per service, either it's master chart approach or the hybrid approach. Those being said, thank you for listening to me. Sorry for overcoming the time limit. Please come to the debate tonight for more questions around Helm or Kubernetes or microservices. I'm welcoming them. Already received some questions down on the floor here. Rate me, of course, because I appreciate feedback. And thank you very much for listening to me.